and good morning to Dr. Wei. Before start the presentations, I would like to introduce myself first. My name is Yin Poei, and I'm student who taking the subject EET 208 Electrical Power Technology in this semester at University Malaysia Paris. I'm from Group 3. Today, I want to make the presentations of project-related simulations and problem showings. Let's start the presentation. I would like to make the presentations first for the introduction part. So what is the Y connections? Because the question is related to Y connected. So Y connections have the parameter that have to be measured, which called the line voltage. Line voltage is meaning the amount of voltage measured between any two line connected in a balanced three-phase system. And another parameter called the phase voltage is meaning the voltage measured across any one component either at load or source winding in a balanced three-phase system. Normally on the Y connected source and root always has line voltage bigger than the phase voltage, while the line current is equal to phase current. Under the balance conditions, line voltage was be the same with the phase voltage times the square root of 3. So what is the 2 wattmeter method related with powers? Because in this project, I use the two method measure the powers. One is the 2 wattmeter method and another is conventional methods. So 2-watt-meter method is measure the power in a three-phase connection system, and the current coil or wattmeter are connected with any two lines, and the potential coil of each wattmeter is joined on the same line, also conjugate third line when using this method to find the power. And this diagram is show about the Y connected pattern. Next, we discuss the objective. In this project, I have three objectives. The first is to investigate and analyze the electrical system formations. The second is to evaluate the parameter of the electrical system in the context of transmission and root impedance, currents, voltage, and acceptable voltage drop based on BS 7671 or any Malaysia authority standard. And the third is to evaluate and analyze the active power absorbed by the load by using 2-watt-meter method and the conventional measurement method. Okay, for this part is about the methodology part. The methodology part also mentioned the step I began doing this project until I finish the project. So the first step is I will start doing my project. And the next step is the value obtained from element they already prepared. This means I take the value already given by the questions. For example, if the line voltage for generator is 30 kilowatts for me, and the volume for transmission rows and root refer to the matrix number, and the data obtained from electricity supply application handbook V3 is at V3. This means there has some value already fixed in these handbooks. Example is the supply frequency is 50 Hz plus minus 1%. The power factor is minimum of 0.85 for water level less than 132 kilowatts. And the next step is the parameter they involve based on theoretical will be calculated. Line currents, phase voltage, line voltage, power factors, and voltage drop. And the active power of conventional measuring method and 2-watt-meter methods. And the next step is change the value form of inductive loop XL to L because the software or PCs they have cannot insert the XL, so just can insert the L. So want to convert first. And the next step is create the files that has the circle YY connection, circle using 2-watt-meter method in the software or PCs. Later, I will construct the circle of YY connection using below element in the PCs. We are using the three-phase sine voltage source, wire, ammeter, voltmeter, and RL branch. And the next, I will add on the information in this circuit. Insert volume line to line voltage IMS, RL branch. Change the frequency to 50 Hz because that is refer to this handbook. Is 1 to 50 Hz. And display all the value in this circuit. Easy to me to see all the value in this circuit. And the next step is the circuit will simulated. So I will put the simulation control in this circuit. So the value of parameter H will show in simulation files and will be recorded. And next, we will construct the circuit using 2-watt-meter method related to the measured active power. And the circuit using 2-watt-meter method was simulated, and the simulation file will show it, and I will record the parameter. And next is the file of these two circuits will be saved, and simulation file will be saved. And I will begin to write the IEE report. IEEE report and refer to the format. And next, the result and calculation of voltage drops was be done. And the next is analysis, comparisons, and discussion done. And last is the end, and I finish my project. In talking about the part of result, the result have the two categories. For the first category is theoretical calculations, and the second category is the experimental data and calculations. From this slide is talking about theoretical calculations. That has the basic parameter they already given by the questions. Because this is the phase sequence of positive, so the angle different from A to B is negative 120, while A to C is 120. So VAB is 33 kilowatts with degree 0, and VBC is 33 kilowatt with angle of negative 120, and VCA is 33 kilowatt angle with 120. And this table 2 is show about the transmission rules and the root. Transmission rules is show the value 64 ohm plus 30 j ohm, and the load is 81 ohm plus 9 j ohm. And then based on the formula, there has some parameter we want to find it. So I want to find some parameter. I want to use the formula. For the phase voltage is using the formula of V phase equal to VL divided by square root of 3. That means it's 33K divided by square root of 3. I get the VAN of 90.05 K, but also same because the different angle. So VAN is get the 90.05 kilo, V angle of 0, and the VBN is get the 90.05 kilo, V angle of negative 120, and the VCN is get the value of 90.05 kilo, V angle of 120. This is our table 3, which is mean the phase voltage calculated. And then next parameter I want to calculate is line current, which means IL. So it's have IAA, IBB, and ICC. The line currents use the formula of this IL equal to V phase divided by Z total. So IAA equal to 90.05 K with degree of 0 from this one. So divided the Z total is the this one plus this one. So get the 64 plus 30J plus 81 plus 9J. The answer is 129.89 with angle of negative 8.63. And the IBB also use the formula of this. So this is a 90.05 K with angle negative 120 divided 64 by plus 30J plus 81 plus 9J. So that the answer is 129.89 with angle of negative 128.63. And the ICC also use this formula and get the 90.05 K with angle of 120 divided by 64 plus 30J plus 81 plus 9J equal the answer of 129.89 with angle of 111.37. And this is the table form which is line current. So next one to find the parameter about the phase root voltage V phase L. So the V phase L is using these formulas IL times ZL. So VAN is get the result of this. And then the VBN also use this formula and get the result of this. And the VCN also use the formula of this and get the result of this. And next one to find the power factor. So the power factor formula is PF equal to cos delta, delta equal to delta V minus delta I. So cos this value and get the cos 6.34 and get the 0.9939, which is lagging. Line of phase current next root phase voltage by power factors of 0.9939. Next is about the result of calculated power. So the power have two methods. The first is the conventional measuring method. So the active power is using this formula P equal to V phase L times IL times cos delta. So how to find the PA? So PA is equal to VAN times IAA times cos delta. Is get a value of like this. So the PA is equal to 1.37 megawatts. Because the three-phase system is under balanced generator and balanced load connection, so that PA equal to PB equal to BC. So the total active power is total these three value. PA plus PB plus BC is equal to this and get the 4.1 megawatt. And this line also want to find the powers, but in this time is using the 2 watt-meter method. So to find the 2 watt-meter methods is first to want to find the load line voltage with load lines. So the V load line is refer these formulas is equal to square root of 3 times V phase L, V angle of the T. So the VAB is get the result as like that. 1855.21 V angle 27.7 voltage. And the VBC also refer this formula. So get the value 1835.21 we angle negative 92.29 voltage. And the VCA use this formula also. So get the 1835.21 we angle of 147.71 voltage. And next one to find the active powers. Active power is refer these formulas which is P equal to V line times IL times cos delta, which the width line is we already find here. So the P1 is VAB, maybe these ones. 1835.21 is time 129.89 times cos 36.34 is equal P1 to 1.92 megawatt. And the B2 is using this formula also. So from table 6, there is not any VCB here. It just has the VBCs. So this means it's VC to B. So that has no VCB. So we take the VBC, C means the VB to C. So equal to this value. So how to find the VCB is just insert 180 angles and get the value of 1835.21 we angle out 87.71 after use this. So the P2 is equal to formula of this. So can find the value. So 1835.21 is times 129.89 times cos 87.71 negative 11.37. So P2 is equal to 2.18 megawatts. Then total active power how to find it is P total equal to P1 plus P2. But it's different with conventional methods because the conventional method has the three lines PA, PB, PC. So that's 3 PA plus PB plus C is for conventional method. But the total active power is just for 2 watt-meter method just to plus P1 and P2 and this one and plus this one, so get the 4.1 megawatts and is get the same value with the conventional measurement method. Next is the part of voltage drop percentage, which supply is equal to V phase and equal to 19050 watt and V drop is equal to V phase L equal to 10585.84 watts. So V drop percentage is equal to V supply minus V root divided V supply times 100%. So V drop percentage is equal to this one minus this one. So divided by this one and times 100%. So V drop percentage is equal to 44.43%. And the next is also the result is the second category, which mentioned the experimental data and calculations. The basic parameter is frequency as stated in Malaysia standard equal to 50 Hz. So I mentioned it's before that in methodology part already. So the L equal to XL divided 2 by F is 1 to convert the XL to the L. So L is equal to 9 divided 2 by 5, 15 equal to this value. And another is 30 divide 2 by time 50 equal to this value. This is the inductor part. So it's the 9 and 30 I already mentioned before that. And this is the result that I get the simulation. So in this software PSIMs, this is the circuits, Y connections, circuit project, Y to Y connector I draw in the software PSIM. So this is the data of a parameter I want to find it using the simulations. So the line voltage VL, VAB, VBC, VCA is get the same value they get from the questions and theoretical. So it's 33 kilowatts. And this table is volume simulated voltage. VTLs in V1, V2, V3 is equal to this one. And the table 9 is volume simulated load line voltage. Is the load line voltage with load lines VAB, VBC, VCA is equal to 80.328, 80.300, 80.327. And the next is the table 10 is value simulated load line currents. Line currents I already before have using this parameter to calculate the theoretical calculations, and from this is IAA, IBB, ICC, and INN. So where's the INN? INN is this line. This line. So the IAA, IBB, ICC is get the result from simulations, which is IAA 129.919, IBB is 129.266, and ICC is 129.187. It's just a little bit approximate difference. So it's approximate same value. So the INN is 0 because it's connected like this. So they have no current inside that. Also can see the VAB and VBC, VCA also like a little bit approximately difference only. So this is classified as the approximately same value. And the table 11 in volume simulated load phase voltage. We see VNN, VBN, VCNs, and VN is get the 10.588, VBN is get the 10.569, and the VCN is equal to 10.569. So this VBN and VCN is the same, and the VAN is 10.588, but it also little bit is different, so it can classified as approximately same. So this is the simulation controls. Want to prove it. So after prove it, so can doing the simulations, and the simulation files will show it, and you can record it. You can record the data and fill in this table. In this slide, I want to find the power factor. But in this power factor, just recorded from the simulation. No need to using the formula to calculate. So the data obtained from simulations is equal to 0.994. So in the power, I want to find the conventional measurement method is refer this wire connection circuit project is get the 1.367 megawatt from simulations in PA, PB, and BC. So P total is total these three values get the 4.101 megawatt. And next is the another method is to meter method circuits. So I use the PSIM to draw of these circuits because I want to find the 2-watt meter method circuit of simulation result. So the power AB is get the 1.921 megawatts, and power CB is get the 2.159 megawatts. And the total active power is for these two watt-meter method circuit just total PAB plus PCB. So it's get the 4.08 megawatts. It's approximately same with the conventional measuring methods. We just can assume same. Slide is talking about discussions. So what is the discussion of my project? First is the theoretical calculation of the circuit of one wire connector which has the line voltage 33K bigger than the volume of phase voltage which volume of 19.05K. The second is the line current referred to the table 4 got the same value of magnitude within IAA, IBB, and ICC but different of values angle due to the positive sequence. The third is the load phase voltage referred to the table 5 got the values of magnitude about 10.58584K smaller than the line voltage 33K. And the fraud is the power factor that calculated using formula which get about 0.9939 watts suitable because it's matched with the regulation or electricity supply application handbook V3 ISA V3 which reach minimum 0.85 for voltage level less than 132 kilowatt. 5 is for theoretical calculation the active power calculated which using the conventional measuring method got the value within PA, PB and PC power got the same value which is 1.37 megawatt due to reason of this type of system under the balance condition. 6 is the receiver of circuit using 2-meter method got the same value of magnitude with the VAB but different in angle. The 7 is the total active power get the same value within conventional measuring method and 2-watt-meter method. 8 is from the experiment data they have obtained by the software which called the PC refer to the table 7. The value of the line voltage after simulate within VAB, VBC and VCA got the same result with the line voltage based on the equation. The simulation result matched with the theoretical calculation in load line voltage, load line current, load phase voltage, and power factor. And 10 is there was no current which I4 at connected with neutral. And 11 is active power using conventional method and 2-watt-meter method measure get the same value. In this slide is talking about the conclusions. What is the conclusion of my project? I have three conclusions. First is the phase currents of all three phases are of the same magnitude as the line currents in this system. And the second is 2-watt-meter method was sufficient when find the total active power. And the third is the circuit of using 2-watt-meter methods that's constructed using phasing easier and simpler compared to circuit which using the conventional measuring methods. Okay, that's all of my presentation about my project. Thank you for Dr. Reed listening and everyone. Thank you.